Hello everyone, this is our team, myself Tarun, Tamo and Shrutika. Here's a project titled Smart Mirror Display using Arduino. This project falls under the Embedded Systems and Internet of Things domain. The main objective of this project is to transform an ordinary mirror into an interactive smart device capable of displaying real-time information such as weather, temperature, etc. By using a smart mirror display using Arduino demonstrates how IoT and embedded technology can transform a simple household object into a multifunctional smart device by integrating sensors, OLED module, and internet connectivity. The mirror provides real-time information such as time, temperature, humidity, etc. This project not only enhances comfort and convenience in daily life, but also showcases the growing potential of IoT applications in smart home automations. In the future, we aim to expand these features by adding voice assistants and mobile app integration to make it more interactive and intelligent. Thank you.
I will be explaining a working methodology of our project titled Smart Mirror Displaying System using Arduino. Now, in our prototype, instead of using an actual reflective mirror surface, we have used a 0.96-inch OLED display to represent the mirror's digital interface. So the OLED acts as the display portion of the smart mirror. Let's see how it works. The system is designed to automatically show the temperature, date and time whenever someone comes near it. It builds using simple and compact components: Arduino UNO, PIR motion sensor, DHT11 temperature sensor and the OLED display. Here is the step-by-step following process. Motion detection. First we have to detect the motion. When someone comes in, the motion is detected. The PIR sensor keeps monitoring the area in front of the mirror. When a person comes close, it detects motion and sends a high signal to the Arduino. Sensor activation. Once motion is detected, the Arduino activates the DHT11 sensor to measure the current room temperature. Time and date generation. Instead of using separate real-time clock module, we have used Arduino's inbuilt millis of function to calculate time and date values. This function counts milliseconds since the program started and helps us simulate hours, minutes, seconds and even day count. Display control OLED as smart mirror screen. We have to display in the OLED instead of a mirror. Normally the OLED stays off to save power. When motion is detected, it automatically turns on and displays temperature in Celsius, stimulated date as day 1, day 2, etc. Time in hours, minutes and seconds. So the OLED acts as the digital face of the mirror showing real-time information. Automatic turn off. When no movement is detected for a few seconds, the display automatically turns off again, keeping the system efficient and smart. In short, this project acts as the motion activated digital mirror display whenever the OLED represents what a smart mirror would normally show. Delay for periodic updates. Finally, we add delay of 1000. This makes the system update for every 10 seconds, both on OLED and ThinkSpeak. Output explanation. When you upload the code to your ESP32 or compatible Arduino board, it connects to your Wi-Fi network, fetches the current date, time from the internet, displays the date, time and temperature on OLED screen, sends the same information to a ThinkSpeak IoT cloud every 10 seconds. On ThinkSpeak, you can log in your channel and see the live updates in graphical form. It is a present example of how IoT systems combine data visualization, cloud integration, and embedded hardware. Conclusion, and that's how the smart mirror displaying system works using Arduino, OLED display, Wi-Fi, and ThinkSpeak Cloud. Even though it's called a smart mirror, here we use the OLED screen as the display portion that simulates what a smart mirror should show. With a few upgrades like adding a temperature sensor and a weather API, this would become a complete IoT with smart homes used in bedrooms or halls to show temperature, date, and time automatically when someone walks away. Offices or workspace acts as a quick info display that activates on motion, saving energy when no one is around. Hostels or shopping malls can be implemented in interactive mirrors or lobby displays to show weather, time, or proportional info. IoT expansion. In future upgrades, we can add Wi-Fi or Bluetooth modules like ESP8266 or 3CC3200 to sync real-time clock, weather updates, or even a voice assistant. So our OLED prototype can easily evolve into a full-scale smart mirror system with IoT capabilities. The result. Let's now look at the output. When we powered up the system, the OLED first displayed smart mirror ready. Whenever someone came close, the PIR sensor detected the motion instantly and activated the display. The temperature, date, and time were shown in the real time on the OLED screen. When the person moved away, the OLED automatically turned off after a short delay. This improves the system is fully automatic, power efficient, and accurately responsive. Even though it is a prototype using a small display, it perfectly represents how a real IoT based smart mirror piece with your Wi-Fi name and the password. Then we create a Wi-Fi client which helps connect to the internet. After that, we define the ThinkSpeak channel number and API key. These details connect our code to your specific ThinkSpeak channel. We also define an NTP server and time zone. What it helps means it lets the Arduino fetch live time and date automatically from the internet. Then setup function, which is initialization. Now let's look at the setup function. Here we start serial communication and connect the board to Wi-Fi. A small while loop keeps printing dots until it successfully connects. Once connected, we initialize the OLED display. Then we configure the NTP time and initialize ThinkSpeak. Finally, we clear the display to make sure it's ready to show new data. So by the end of setup function, Wi-Fi, display, time, and ThinkSpeak all are ready to grow. Loop function. Main program is inside this loop function. First, we fetch the real-time clock from the NTP server. If the data isn't available, it prints an error message. Then we define a fixed temperature value for demo. In a comes the OLED display setup. Next, we define the display parameters. We are using a 128 cross 64 pixel OLED display and it communicates via I2C at address 0 cross 36. Then we create a display object. This allows us to control the screen, write text, clear it, and display our data. Then comes Wi-Fi configuration and ThinkSpeak setup. Next, we define the Wi-Fi and ThinkSpeak, date, time, and temperature, and will update every 30 seconds, sending data to ThinkSpeak Cloud. After displaying on OLED, we also upload the same data to ThinkSpeak